Imagine our familiar blue planet, Earth, not circling the warm, life-giving sun, but instead locked in orbit around a black hole. This isn't a scenario from a science fiction movie, but a fascinating thought experiment that pushes the boundaries of our understanding of physics and cosmic mechanics. What would such an existence truly entail for our world and everything on it? First, let's clarify a common misconception. A black hole isn't an indiscriminate cosmic vacuum cleaner, devouring everything in its path. If our sun were suddenly replaced by a black hole of the exact same mass, Earth would continue its orbit precisely as it does now. The gravitational pull would be identical, and we wouldn't be sucked in. For a stable orbit, the black hole's mass is the critical factor. If it were a stellar mass black hole, roughly the mass of our sun, it would be incredibly compact, perhaps only a few kilometers across. Earth would need to maintain its current orbital distance of 150 million kilometers to avoid being pulled into oblivion. At this distance, the black hole's event horizon, the point of no return, would be far, far away. We would be safely outside its immediate gravitational grasp, experiencing its pull much like we do the sun's. The primary difference would be the absence of light and heat. This is perhaps the most profound change. Without a star, there is no sunlight. Earth would be plunged into perpetual darkness, illuminated only by the distant stars, and perhaps the faint glow of our own atmosphere. Photosynthesis, the foundation of most life on Earth, would cease immediately. The planet would rapidly cool. Our atmosphere would eventually freeze, and oceans would become solid blocks of ice. Any surviving life would need to be extremophiles, adapted to absolute darkness and extreme cold, or rely on geothermal energy from Earth's core. Even at a safe distance, the black hole's immense gravity would warp spacetime. Time dilation would become a noticeable phenomenon. Clocks on Earth would tick slightly slower compared to clocks far away in the universe, though the effect would be minuscule at our current orbital distance. However, if Earth were to orbit much closer to a supermassive black hole, time dilation would become extreme. Days on Earth could pass, while only moments elapsed for a distant observer. This warping of time would be a constant, subtle reminder of our cosmic neighbor. While a stable orbit is possible, the black hole's intense gravitational gradient would exert powerful tidal forces. These forces would stretch and compress Earth, potentially leading to increased seismic activity, volcanic eruptions, and even subtle changes in our planet's shape over eons. The closer Earth orbited, the more extreme these forces would become. Eventually, if we ventured too close, Earth would be stretched into a long, thin strand of matter, a process known as spaghettification. This is the ultimate fate for anything crossing the event horizon. The sky would be a spectacle of warped light. Gravitational lensing would bend and distort the light from distant stars and galaxies, creating bizarre, shimmering patterns. We might even see multiple images of the same celestial object, or a ring of light around the black hole's silhouette. The black hole itself would be invisible, a perfect sphere of darkness against the star-studded backdrop. Its presence would be known only by its gravitational effects and the distorted light around it. It would be a constant, silent reminder of the immense power of the cosmos. Could life survive in such a scenario? Without sunlight, surface life as we know it would perish. However, life in deep-sea hydrothermal vents, powered by chemosynthesis, might persist. Subterranean ecosystems, shielded from the cold and radiation, could also endure. Humanity, if it were to survive, would need to adapt drastically. We would become a subterranean species, relying on geothermal energy, advanced artificial lighting, and closed-loop ecosystems. Our existence would be a testament to resilience, but profoundly different from life under the sun. Orbiting a black hole would transform Earth into an alien world, a cold, dark, and gravitationally stressed planet. It highlights the delicate balance that allows life to flourish, a balance provided by the warmth and light of a star. This thought experiment underscores the unique privilege of our solar system and the profound impact of our sun. Subscribe now for more awe-inspiring videos.